to start with a broader motivation. How we started to think about this. It's not a secret that these days production of media and consumption is high, as high as it ever was. There is a lot of media produced, so there is 500 hours of video uploaded to YouTube per minute, which puts pressure on YouTube to sort out through this and select what to show to viewers. With also just enormous amount of consumption of media. People spending most of their time awake watching videos, consuming other media products. Now, this puts pressure on producers and distributors of media products in terms of how to design and evaluate ideas. For producers, we need a systematic way to evaluate what to produce, how to design it. For platforms, they need a way to systematically rank the content across a lot of different various products. And this part is really challenging because it's hard to think about video in the same way we think about, let's say, typical products, such as yogurt, such as cars, which have very concrete attributes, partly because video consists of a lot of unstructured data. And also people can value different parts, different attributes. So it's hard to compress all of this unstructured data to a small set of dimensions. This gives a natural flashback to a famous phrase from William Goldman from the 80s that in Hollywood, nobody knows anything, just meaning that it's really hard to figure out which movie, which TV show will become successful or not. And also just looking at even the schedule of this conference, we see that a lot of contemporary work in marketing is trying to understand how to make sense of the unstructured data. For example, the last talk in this session yesterday from Prashant and Puneet was exactly how we can use unstructured data and compress it. So while the motivation of this paper is fairly similar, we start from a somewhat different angle to this. What we're trying to do is understand what are the micro foundations for consumer taste for media, which should be measurable on a fairly large scale, which should be objective up to some belief or some preferences of consumers, and should be addressable by the firm. So particular feature of media products we'll be focusing on today is the fact that these are informational products. So when viewers consume media, when viewers consume video products, they form beliefs about events in this video and ultimately about the final outcome of the video. In particular, there is different ways to summarize these beliefs in video content, but a particular nice way to summarize it was introduced by a paper of Ali Frankel-Kamenitsa recently, where we can think about beliefs converted into matters of suspense and surprise of the media product, where suspense is what is the variance of the final outcome, of the variance of beliefs about the final outcome of the video, and surprise is how much these beliefs changed as we consume the product. The paper itself and the Ali Frankel-Kamenitsa paper is more of a theoretical paper about product design and the limits, how much we can push push beliefs and create very suspenseful and surprising products. But ultimately, it assumes that there is some preference and taste for this non-instrumental information. So this really starts the project here. What we'll try to understand, and it's a very kind of pointed question in some way, is how much this non-instrumental information drive demand for entertainment. Two particular features here. One is we really care about direct effect of suspense and surprise and beliefs on consumers, not about some indirect effect of supply responses, partly because we want to understand how we generalize to other video content. And also not only want to test if it matters, we really want to measure what is the relative importance of these belief-based measures in consumer taste. So this, one of the challenges here is that now we need a context where we can observe a media product which has a lot of frequent changes in beliefs. We also want to get enough data so we don't observe beliefs directly, so we need data to measure the beliefs and convert them into metrics of suspense and surprise. So this is really where this paper starts and what this paper is trying to do. We'll focus on a particular empirical context, which is esport tournaments on a platform called Twitch, which I'll talk about in a second. The nice feature of this context is it has a very rich data environment. We can collect data on minute-by-minute viewership decisions of people on these platforms. We can collect data on in-game events which happened on the streams, which will be streams of tournaments that people will play. We also have data on historical records of the game outcomes. We use this data to construct matters of consumer beliefs. So it's beliefs about, given the current state of the game, what do we expect the outcome to be? And this way we can form a minute-by-minute measure of suspense and surprise, given these beliefs. So now you can see how even within one game, we can see what happens with viewership as the path of suspense and surprise evolves in a particular way. We write down a simple model of entertainment consumption, which includes preference for suspense and surprise. And the key in the model will be separate decisions of people to join and to leave the stream. This really will help us to identify direct effects on demand, because people who watch the stream, these people who know what's happening, this is the people who get some effect of suspense surprise, versus indirect effects, people before they join, they wouldn't know what's happening in the video. And finally, we'll take this model to data, estimate consumer tastes using the within game variation, but not only estimate in terms of testing if it exists, but also try to measure what is the relative importance of these two, of suspense and surprise in choices of consumers what to watch. All right, so quick preview of what we find. What are the results? We find evidence of suspense impact on consumer utility. A roughly 1 standard deviation increase in round suspense leads to around 1.5% higher viewership. So this part is tricky to interpret, because even though we talk about 1 round increase in suspense, because suspense will be correlated across rounds, think about it's a different path. It's a higher, more suspenseful game overall, which leads to this higher viewership. This is primarily driven by people who choose not to leave the stream, not people who choose to join the stream. So it's driven by tastes of people who already are consuming the product. On the surprise side, the impact is 3 times lower and statistically insignificant. At the same time, I'll mention that there is no nice identification for us to separate out the effect of suspense and surprise. So both will be functions of beliefs. And think about this as more a correlational argument. So this measure of surprise correlates much weaker with viewership decisions than suspense. And finally, when we're trying to separate out what is the relative importance, we find that realized suspense drives around 8% of observed evolutions of viewership. So this, hard to say if it's a lot. We think it's quite a lot, 8%, because this is very simple matters, which now can help video producers and designers to choose optimal product, but also opens up a question of what else might be driving this viewership decisions. All right, so before I go in more detail into the paper, quickly how it fits into the literature. Very broadly, it fits into the large literature on product design and tastes for media, which is enormous. So in video itself, half a century ago, we have work which started on trying to think about videos as attributes from Don's work in 1971. And as we can see, 50 years later, we do fairly similar, we try to address this question in a fairly similar way, but with much more sophisticated tools, with the paper by Olivia, with paper by Matt, with a paper from yesterday's session by Prashant and Puneet. There is broader literature on media consumption across different areas, such as radio, newspapers, video games, etc. So that's the first part. This also fits in the literature on understanding preferences for gradual resolution of uncertainty, because you can think about suspense and surprise and belief paths as a gradual resolution of uncertainty. And finally, it fits into a small and probably most related literature on how emotions drive demand for entertainment. So the first part is more about suspense and surprise as emotions. Our work is more related to belief-based suspense and surprise. There is several papers which try to get at questions related to what we're doing. So probably the most related paper here is the last one, the paper by Shao, Kosuke, and Matt Shum, who look at suspense and surprise as driving attention for video content. What really differentiates our paper, so first, from the rest of the papers, we're trying to get at effect of suspense and surprise on consumption and how it enters the utility. And so this, by this, we're trying to understand how it generalized much broader than a particular context. Shao's and Kosuke's paper is trying to get at the same also at consumer side, but with very different methods. So instead of using attention data here, we'll be able to figure out this preference and separate them out just from simple choice data. And so that's kind of the contribution of the paper, while going in the same direction will be slightly different. All right, so with this, so for the rest of the talk, I'll go quickly with 5 steps. So I'll talk more about the empirical context we're looking at. I'll talk what kind of data it can give to us. Then we'll use this data to measure beliefs, suspense, and surprise. So this will make things much more concrete. We'll build a simple model of entertainment consumption, which will accommodate suspense and surprise. And finally, I'll give you some results of this estimation. Before I go into this, any questions people have so far? I don't see the chat in Microsoft Teams, so just feel free to unmute yourself if people have any questions.
Andrey?
Yeah?
Hi, it's Jason. Good to see you again. I have a quick clarification about suspense. So would it depend heavily on time? So as time progresses, there's less expected variance in the content, right? Because you have less content available as time progresses. So do you observe suspense decreasing with time?
Not so. I'll show. It's not necessarily. It's first decreasing and then increasing. I'll show you in a second how it looks. But all the analysis will be including kind of time of the stream fixed effect. So like, what is the stage of the product fixed effect?
Okay, thank you.
I'll show this in a second. All right. By the way, I hope that people can see me because I cannot see myself. So hopefully my video and you can hear me well. All right. So then with this, let's go into the content of the talk. So first is, what is the empirical context here? We look at the platform called Twitch, which is the largest video game streaming platform in the world. So this is the 14th largest website in terms of traffic. It attracts around 4 million unique streamers, or attracted in early 2020. During pandemic, it grew even further. For a lot of streamers are the content producers here, and for a lot of them, this is a full-time job. They make money on donations and on subscriptions of people who watch the stream. But viewers can watch the product, watch the streamers for free as well. So anyone on the platform can come to any streamer, click, and watch the content. So you can think about this as somewhat a freemium product. But for a subscription, you get additional perks, additional features. You also just do donations if you want to support what the streamer is doing. And Twitch as a platform gets money off a share of this transactions of viewers to streamers. Here is how Twitch looks. So you get to the website, there is a bunch of streams here which you can choose from. You click on the stream, and then you see something like this. So this is a particular streamer who has now 10,000 people who are watching this stream. There is a bunch of people who come to the stream. They also interact in the chat. And so there is a slight difference between people who watch it, which is just any users will be counted here, versus registered people who watch and are in the chat. So in the chat, you can click and observe all people who are currently on the stream, which now gives you some idea where we'll be getting a lot of our data from. So this is Twitch. Our focus will be on esport tournaments of particular game, which is called Counter-Strike Global Offensive. So this is a game which was somewhat popular when I was a kid, which was an easy way for me to get into this project. So one thing to note, this streamers here, so this person is streaming his own game, but a lot of streamers will stream professional esport tournaments. Counter-Strike is what's called is first-person shooter game. And in tournaments, you have two professional teams of 5 players each who will compete in a well-structured sequence of at most 30 rounds, with team going to 16 rounds, winning the game. This is somewhat a large industry these days, and it's growing around, I think, 10% a year, with Counter-Strike, these tournaments attracting a large audiences, and major games, which is this large tournament games, having prizes of more than $1 million. This is really a perfect sandbox to study suspense surprise. This is very frequent and popular events on Twitch. So even if you go now, you likely will see some kind of small tournament going on. It's very dynamic. There is a lot of rounds. There is clear objective to win the round. You need to kill 5 people from the other team or get some local map objectives, such as planting the bomb. And so from this, the score of the rounds, we can get a clear idea which team is leading right now and get some form of belief about which team ultimately wins. And then this also closely resembles regular sports, as esports, other esports. Yeah, there is a question? All right. To give you an example, here is how these tournaments look like. So this is from, I guess, pre-pandemic era, where there was this 2 teams of 5 players each. I'm not sure if you can see my mouse, but I'm trying to circle them. This is blue and yellow on the stage. And then there is an audience watching it just as regular audience will watch a regular sports game. In the game, here is how like one round will look like. There is, as I said, there is 5 players on each side. Again, not sure if you can see my mouse, but there's a blue bars and yellow bars on the sides. In this case, 2 blue players already died, and then there was a fight between these 2 players on the screen and on the screen. There is teams what's called terrorists and counter-terrorists, which is not really relevant for our purposes, but there is some roles in the game. What's important for us is this is a 1 round, which lasts around 90 seconds. And then on top of the screen, you see the current score across rounds. So this is round 6. The current score is 2-3 with the yellow team leading. So this is how a typical round will look like. Okay, so this is our empirical context. We look at Twitch. We'll look at this Counter-Strike games on Twitch. Now let's see what kind of data we can extract from that. First is we go to Twitch and we collect viewership data on 60 professional matches of this Counter-Strike games in August, September 2019. So these matches are sometimes best of 3, not best of 1. So it gives us around 104 games at these 30-round games. There is around 50 games of these are majors, so large tournaments, 10 are smaller tournaments. There is around 43 unique teams playing in these matches, so there is some overlap of teams progressing in the tournament. And in total, it gives us 2,700 rounds. So this 104 games have an average around 26 rounds a game. From Twitch's APIs, and that's where Carolina's heavy lifting of data became very useful to us. She did an amazing job collecting all of this. We can grab both total data for all viewers and registered viewers or chatters. On top of this, for chatters, we can collect individual level data, which chatter is going from one stream to another. So we can collect how many people join versus leave the stream, which gives us around 1.4 million users who watch games on average for around 13 minutes. Here is quick summaries of viewership data. An average game have 78,000 viewers and 50,000 approximately chatters, but there is large variance across the games. On average, so we get this data every minute, and so given that an average round is 1.5 minutes, for most rounds we have an update of viewership, but then sometimes the change in viewers is 0 just because round was extremely short. but on average, around 6% of people join every round, and around 4.7% of people will leave. So there is a big attrition and turnover of people who are watching this. In terms of viewership levels, here how they look across the game. So this is log number of viewers across 104 games. And you can see that fixed effects really drives the most difference in viewership. In terms of evolution of viewership,
Andrey?
It slowly increases. Yeah.
Andrey, can I ask a question?
Sure.
So for this round, are each round like a separate as the players? Do they make independent decisions, or like, is it something carry over from one round to the next? And does the viewers take this into account?
That's excellent. So yeah, so there is it's mostly independent in a sense of every round you again start with 5 people all alive on each side of the team. There is some dependence across rounds though, and this is because for example, early on if one team wins round 1, they get extra money they can spend in round 2, and this gives them some advantage.
I see.
So what will be computing the beliefs? I'll talk in a second how we compute people's beliefs about which team wins. It will be really important for us to say, well, if the score is 1-0, meaning the other team just won, what's the likelihood of this team winning the next round again? So there is, to your question, it's mostly independent, but there is some forms of state dependence in this.
Thanks.
That's a great question. All right, so this is just viewership on the levels. Final thing I'll show you about viewership is over the course of the game it increases. So I normalized this early viewership to 0, and this think about this as round fixed effects on the log scale level. So from round 1 to 30, viewership increases by around 55%. It's almost monotone. There is a small gap here in the middle, and this is because teams take a 10-minute break after round 15. So this is some viewers decide not to wait for the second part of the game. All right, so first we grabbed viewership. Now, second thing we collect is information on game events. So again, what Carolina was able to do is while the stream is running on Twitch, she collected what are the events which happen on the screen at this time from a separate website, hltv.org, which tracks CSGO tournaments. So from this we know team information, so which is of a fixed thing for the game, but also number of rounds in the game, what happened within the round, how many players were killed, at what seconds they were killed, etc., and importantly, round outcomes. So as I said before, there is an average game has 26 rounds from 18 to 30 in the data. On average, rounds go for 88 seconds, and then the game is fairly balanced. The terrorists win roughly half of the time, the rest is won by counter-terrorists. So finally, this is data on games we collected. On top of this, we collect historical information on 45,000 games which happened in the past. And this we collect to measure beliefs of, given the score in a particular time, what is the probability the team will win? Because for each of these games, we know the evolution of scores, we know what is the eventual outcome. We keep 36,000 games, drop in a bunch of games which have incomplete records for technical reasons. All right, so now we saw empirical context and data. Any questions at this stage on this before I go into how we now measure beliefs and build the model? All right, so now first thing we want to do with this data is convert the observed events and historical records into a measure of beliefs. Some notation, and in this we closely follow Ali Frankel-Kamenitsa paper. We'll think about a game or a stream as a product which can end in 2 outcomes, which team A or team B eventually wins. So this is omega. At time t, which is round in our context, a consumer holds a belief, which we'll assume is rational, meaning that consumer correctly informs information from historical records. The belief mu t, which gives the probability that eventually team 1 or team 2 wins the game. So this is, think about this as belief conditional on the realized score. Mu-T itself is a realization from a belief martingale tilde mu, where tilde mu is built in with the game design. So if I am CSGO producer, I'll decide how to give benefit to one team or another, and this will determine the probability one team wins or another and gets to a particular score. So mu-T is just a draw from this mu tilde, where eta is a sequence of realized mu-T. So for each game of 30 rounds, the evolution of rounds defines mu-T, because for each round score, we get a belief what will happen in the end. So the final thing we need here is complete the model with the prior belief before the game starts. We set the probabilities of winning to 50-50 in our main analysis, which is before the game starts, score is 0-0, each team's an equal probability to win. We did robustness here on trying to account for difference in kind of rankings of teams. It doesn't seem to shift the suspense surprise measure by a lot, so and ultimately our results. This is something we are trying to tweak it and try to get the best way to measure this to avoid this measurement error type of problems. But our results hold even this kind of more crude assumption on the prior. All right, so this is viewers' beliefs. How do we go to suspend and surprise from this? Given the belief martingale, the distribution, and a particular realization, we can now convert this into matters of suspense and surprise. So you can think about suspense as the variance of my belief in the next period given the current realization, or so I should say standard deviation of this. So this is just a measure of uncertainty. Surprise is by how much my belief changed from T-1 to T. So this is function of belief and distribution and the martingale, and this is just a function of the realized belief. And we set surprise at round 1 at 0. Okay, so this is definitions. Now let's take it to the data. We have our 36,000 historical games. This gives us less than 1 million, that 900,000 round level data points of what is the score and what ultimately was the game outcome. Given we have only 250 combination of round scores to estimate, we can use a simple frequency estimator. So for each score, we can get the probability which team will ultimately win. Again, our main specification is unconditional. We're trying to reduce the measurement error by doing robustness, by accounting for difference in the team rankings, by how much money they had, things like this. But you can see how this starts to slice our data, and now we cannot use frequency estimator. So it's something we're still trying to figure out. To give an example, for the round score now is, let's say, 3-6. Team A has 31% probability of ultimately winning the game. It's behind. In T+1, scores can be 4-6 or 3-7. We know what is the probability if those scores get realized, and we know with which probabilities the game will take this path. Okay. So finally, this is beliefs. Now we can estimate our matters of suspense surprise. And this in the bottom, now we plot the potential evolution of suspense and surprise matters to the question we had earlier. The median round has around 0.09 suspense and 0.085 surprise with a standard deviation of 0.5. All games have fairly similar suspense and surprise in very early and late rounds. There is big difference in the middle. For example, if it's round 11, score is 5-6. It's much more suspenseful than if score is 0-11, so which is intuitive. There is a substantial correlation between suspense and surprise, around 46%, and so this is where our test between these two matters at best will be correlational. So they don't coincide ideally, so we can see which one is correlated with viewership better. But there is no instrument which will shift one or another. Both are function of the realized beliefs. Finally, some games just happen to be very suspenseful and surprising, and some are not. And here the correlation is much higher. So on the game level, because once you sum up suspense surprise for the game, a game which is suspenseful is also very surprising and vice versa. which tells you why we need this within-game variation to measure the effect.
Andrey, quick question.
Yeah.
It's Brian. Is there any evidence that viewers can anticipate score changes? You know, if a player has a really nice elevated position and you know they're going to take someone out, it seems like some of the things that's coded up as surprise might not really be surprised if they can anticipate that that's sort of an inevitable thing that's about to happen, essentially. So I don't know if you were able to explore whether sort of upcoming changes were anticipated or not.
Right. Now, that's a great question. So we try, the best we can do with this, we try to include a bunch of other features from what happened in the round as controls, like how many people died in the round. Was it like a 0-5 round, everyone died very quickly, or was it a close round? Those things I'll show you in the areas. Those things just don't tend to drive viewership at all. But this, I don't have a better way to kind of try to resolve this. So it's a good question. By suspense, we mean all those other events which might make round more suspenseful. That's a good point. All right. So with this now, time. Okay. So I'll quickly go through the model. Luckily, it's very simple, and get to the results. So we'll estimate a very simple model, or a choice model, where people decide which stream to watch. We'll start with consumer I, who is already currently watching stream J on Twitch. At each period, which is round T, this consumer will get the following utility. There is preference for realized suspense and surprise in the game and the corresponding tastes. There is alpha J, just fixed preference for the stream, row T, which is fixed preference for a particular stage of the game, some other features, as Brian just alluded, what happened in the round, idiosyncratic shocks for the round game shocks, and some IED component of consumer level shocks. The outside option of just leaving the stream will normalize to expected utility of 0. So important here is we'll think about this as static choice model, but the way to think about the suspense and surprise matters. This is belief martingale, so my current suspense is the best guess about the evolution going forward. So this betas also includes a reduced form for my expectation how suspenseful the game will be in the future. Okay, so this is what happens if I'm on the stream. Let's see what happens if now it's consumer IG.
Can I ask a clarifying question? So you're assuming that the C and epsilons are not carrying over time, right? But only the suspense, all the sort of like in this reduced form, you're assuming that all the dynamic components are summarized that suspense and surprise, those two variables that you have constructed. Am I understanding correct? Okay.
Correct. But notice that Xi, so everything there can be autocorrelation in Xi. So ultimately, we'll cluster standard errors on the stream level. So all I want to say is the way to interpret these betas.
So this model is kind of still kind of like sustains the component of the dynamic model, but the difference is like they're not strategically planning over the future periods or something, right? So that's the difference.
Exactly. Somehow that's exactly right. And so what helps us here is that we assume that we follow Eli Kamenitsa-Frankel, assuming that suspense surprises beliefs are martingales. But you're exactly right. So there is some still assumptions baked into this.
Sounds good. Thanks.
All right. So this is person.
Sorry to interrupt. You have 10 minutes left.
Oh, perfect. Okay. So this is person on the stream. Now let's see what if the person is not currently on the stream. So this is a person who is on Twitch and considers whether to join. We'll keep the structure of utility of this person exactly the same as the person on the stream, but allow all coefficients here to differ. And so a particular interesting part here is what's the way to interpret this beta bar on suspend and surprise. This is a person who is not currently on the stream. This person has no idea what's going on, and will expect suspend surprise has no direct effect on this person's expected utility from the stream. But it will have effects through any supply side or indirect demand effect. For example, if the stream is high in the ranking, if I get an email from a friend, go there. So by this we try to measure supply side factors, but also it gives us a test for do these betas actually correspond to consumer actual preferences? So otherwise, structure is very similar. From this, fairly simply, we can just we assume a parametric form on epsilon and use Berry 1994 to write log odds ratio equations, which now can regress directly because we observe this in the data. We can also give different parametric assumptions and epsilons. So I'll show you results are consistent, are robust to using a linear probability model. So nice thing about this model is now by observing this, we can estimate betas just directly with linear regressions from the data.
One thing, can you remind me from where you observe those probabilities? Are these estimates or?
Great. So this we observe individual level data on people joining and leaving the streams. So these probabilities come directly from our. I'm trying to go back from the probability of chatters to join and to leave the stream. So this is for each round we see over this time how many people chose to leave or to join.
And they're fairly large, so you don't observe any zeros and stuff, right? So that's what you're saying.
There is a bunch of zeros for the moments when we grab it every minute, and sometimes the snapshots are too close, so we haven't. The round lasted only for 30 seconds, so that is score I haven't updated. I'll show you. Basically, we treat zero in the main thing. We treat zeros as just the lowest update we see in the data. We can also drop zeros and get robustness. So I'll show you those in a second. This corresponds to around 400 rounds out of 2,700.
Okay, sounds great. Thanks.
All right. So final thing in the model before I go to results is we can estimate these two equations directly and get to betas and beta bars. We can also express the total number of viewers as what happens with viewership due to people staying on the stream and people leaving. So we have VJT, which is the total number of viewers, on JT, and then a bunch of people who decide to leave and to join. In our main model, we assume that number of people who consider joining is the same as number of people on the stream because we need a realistic set of how many potential people who arrive. Again, this is something we can do robustness on. One thing we can get from this model is that VJT is an increasing function of X beta suspense and X beta surprise. So one thing we can do, even if we didn't observe this data, is just to run a reduced form model regressing log V on suspend and surprise and get some parameters beta prime. In fact, this is what most of the papers trying to get this question are doing. But now it shows you how it's really hard to interpret the magnitude here because these magnitudes are convoluted effect of different propensities to stay on the stream before or to join it. So we'll just do it to get the direction of betas. Okay, so finally, we'll estimate these coefficients directly from these three equations. We'll cluster standard errors on the game level to account for potential correlation in size. And the key unification assumption to Brian's question is that controlling for stream fixed effect, time fixed effect, the size, these additional things which happened in the round are not correlated with realization of suspense. So that's what we're doing.
Oh, wait, so I'm a little troubled by this identification assumption because the suspense and what was that, the other one? I just forgot. But anyway, they are martingale over time correlated. So I'm not sure whether just conditioning on the contemporaneous factors xjt and then just controlling for the j controls will control for all the components that are like carrying over time, right? So is that a reasonable assumption?
So look, again,
I do think that the beta coefficient would be attenuated.
So let me, I'm happy to go to this question more in detail offline just to make sure I can stay on time and show the results. The way I'll think about this is that Xi can be perfectly correlated over time. That's completely fine. It's just how we interpret suspend and surprise. So like how much the current suspense is also represents what's this potential dynamic decision of me go kind of not accounting that I'll choose optimally because I predict the future suspense. And so in my mind, this is how we interpret these parameters. But I'm happy to talk about this offline afterwards. I'm on time here. All right, so final thing I wanted to show is now what do we get as results? And for this, so I'll skip and I'll go more quickly through the reduced form part for the sake of time, but just from the reduced form, both suspense and surprise are well correlated with the evolution of viewership after we control for the round and game fixed effects. What I wanted to kind of focus a bit more on is what we get when we estimate the model using the logged odd ratios, where if we look at decision to stay on the stream, so this is now we're getting at the betas, we get that increasing the suspense of a round within a stream predicts this viewership evolution fairly well. Increases the probability to stay on the stream. We don't get such relationship with the surprise. And this, Joonhwi, to your question before, this is called similar if we treat zero change rounds by using kind of the minimum change we observe, or just if we drop them from the data. In terms of magnitudes, this one standard deviation increase in suspense leads to around 0.04 extra utiles, which is 4.7% increase in the odds ratio. So this is a fairly small increase in probability to stay on the stream, but it quickly compounds over the round. And this shows you again why we cannot use just overall viewership in this analysis. Because in overall viewership, extra suspense of the round also corresponds to rounds next to it. Here it's about people who choose to stay on the stream, which accumulates over time.
Sorry to interrupt, you have 2 minutes.
Yeah. Perfect, thank you. And so now this was decision to stay on the stream. We can do the same on the decision to leave the stream, and now results are very different. So now there is no detectable effect of suspense or surprise on this decision. So again, given as a task, it's really about consumers who are already seeing the product and not some indirect supply side effects. Yeah, question? All right, so then I'll skip robustness here. So we do robustness with change in probability definition with a linear probability model. If anything, results are slightly stronger with magnitude slightly higher. The last thing I'll show here is how can we get at the relative importance part. We'll use model estimates now to simulate viewership under different ADAs, different evolutions of games, very suspenseful or not suspenseful at all. And so we'll just...
This is the same estimator that we used.
Say it again? Artyom? I think it was you. Okay. So now we'll simulate this viewership for different realizations of ADA. So first, for the game with the highest suspense pass we observe, this was the game which was tied up 7 times. The evolution of viewership is the red line. It increases from 1 to around 2.1, so a total of 105% increase over 30 rounds. For the game with the lowest suspense, which went only for 21 rounds, and this had a score of 11-0 at some point, this increases by around 54% versus 66 for the highest suspense, so blue versus red line. Finally, for the game with lowest suspense, which went to 30 rounds, this has an increase of around 85%. So this gap between the red and green line gives a total effect of the evolution of suspense on the evolution of viewership. To put this in context, and this is, I'll wrap up after this, now we can plot the same evolution for all games in our sample. And so here, the scale is very different, so you can see it by the grid lines, but across all observed games, the end evolution viewership have increased from 122, so 22% to 263%, so the range is around 240 percentage points, which tells us that this effect of suspense on viewership is around 8%. Putin is kind of giving us some relative importance. All right, so I think I'm out of time or close to out of time. So with this, I'll conclude. So what do we do in this paper? We examine the role of suspense surprise in consumers' demand for entertainment. We use choice data without augmenting with eye tracking or any attention data to really separate out demand and supply and potential supply side effects. For this, we leave the individual level data with lead versus joint decisions. And so it quantifies the importance of this non-instrumental information in the video and see that explains around 8% of observed viewership. With this, thanks a lot, and happy. I don't think I have time for questions now, but happy to connect offline if any other comments, questions come up. Thank you. All right, Matt, do you want me to share the slides so you will figure what to do next?
Yeah, that'd be great if you can share the slides. Okay, can you hear me?
Yes, I can hear you. So I'm opening the slides.
Yeah, PDF is perfect. And I'll just give you like a hands up, or I'll just say next. And so, hi, I'm Matt McGranigan.
Matthew, you may want to try on top of the screen. There is a request control thing that you might see on the top.
Yeah, I don't want to spend too much time. I pressed request control. Andrey, do you see anything?
Allow? Yeah, I can see that.
I'm touching things, but it doesn't let me do anything.
All right, okay, Andrey, why don't you go on?
So if you're willing to control, that would be great. I only have a few slides. And so thank you to the conference organizers for inviting me, and for the authors for writing such a kind of fun paper. I'm going to keep it simple. The authors already have a great paper, and they have really innovative data. I'll try to give it my thoughts and interpretation, as well as a few suggestions for what could come next. And so, next slide. I'll start with a win probability graph. And so I love these graphs, whether they be politics, sports, games, they tell amazing stories. And so I chose an example from Dallas, given the conference here. And so this is an ESPN win probability graph from week 2 in the NFL. When the Falcons were kind of all but sure to win. At one point, they were at like 99.9% probability of winning, and then the Cowboys brought it back. And so this graph kind of nicely encapsulates kind of the two key constructs that the paper kind of looks to measure, which are these ideas of suspense and surprise. And so right after Dallas scored a touchdown, we see a drastic change in beliefs, or in the model's beliefs about the outcome of the game. And so this is surprise. Whereas kind of right after that, when we're sitting at about 50-50, any team here could score and drastically move the odds of winning in their favor. And so this is a moment of very high suspense. And so these things are all around us. And so we'll go to the next slide, which is they're in the context of these esports. And so here is a win probability graph for a Counter-Strike match that I made up between two big teams. This is based on actual win probability data from that kind of amazing website, HLTV. They have so much data. It's kind of nuts. And so in the stylized example, we could see moments of high suspense and high surprise as well. And so my initial reaction was that these concepts, like, why can't we just throw win probability into the utility function? And I thought about it some more. And a win probability is probably not something that belongs in a utility function. Whereas surprise and suspense, on the other hand, those are good candidates for things that kind of theoretically should be in a utility function. And there's been a nice series of papers, not a complete list, and so Lou et al. Should also be on here, that say that kind of, well, first intuitively, kind of suspense and surprise matters, but it's also been shown to matter in the context of tennis, soccer, and basketball. And I'll talk a little bit why I think this paper has some advantages over those papers. And so we'll go to the next slide. And so first, I just want to talk about a few things that I really liked about the paper and how the authors answered this question of, do suspense and surprise matter? And so the paper really marries these two amazing data sets, kind of Twitch and CSGO data. And so on Twitch, we have kind of millions of viewers. You have these incredible APIs where you can kind of track at a very granular level the number of viewers, the number of chatters, that is the number of logged in viewers, as well as the explicit chat ID. And so you can just like type in an API link into a URL and it will output a list of hundreds of thousands of chatter IDs. And I thought this was kind of an amazing public good for researchers like us. So I love it when I see these things or when I learn about new data sources. And so I definitely learned about a new data source here. And combined, what that gives us is a really relevant and useful audience panel. And so these aren't just random people. These are an arguably valuable demographic for marketers. And so this is a group it's useful to study. And we marry that with the CSGO data. And this has, I think, a lot of nice properties for studying these questions of suspense and surprise. And so I mentioned kind of these other papers also on sports that talk about tennis, basketball, and soccer. Like tennis and basketball, things frequently happen in Counter-Strike. And so this makes it relatively easier to model things like a win probability. I mean, it's still not easy, as well as describe the flow of the game, which is important for modeling beliefs. Kind of a slight kind of downside around things frequently happening is that the end of every round doesn't change the win probability by that much, as opposed to a sport like soccer, where one goal can drastically change the beliefs around what's going to happen in the game. And you see that in the I forgot the name of the paper, Biriamo paper. And so another advantage is that the competitive scene is young. And this is important because people do care about the outcomes of specific teams and players. And so in the case of Counter-Strike, you have kind of a little bit less, arguably less kind of brand allegiance or fandom than in those others. And Bizzozero actually make this point or make the compliment, which using data from a Swiss TV audience analyzing Wimbledon, they estimate different coefficients for surprise and suspense for the national favorites. And so for Roger Federer, who's a Swiss player. And so fandom does play a role. And so by being able to not have to worry about fandom, that's an advantage. And an important managerial piece is that the game is malleable, unlike basketball, tennis, and soccer. That is, you can actually change the rules. And the companies do change the rules a lot. And so sometimes they're big changes, sometimes they're small changes, but the policy recommendations that come from papers like this could actually mean a whole lot in terms of actually changing the game. And so we'll go to the next slide. And so I'll focus on kind of a couple of the results that I liked the most. And so first, the authors kind of find really nicely that consumption utility increases with suspense, but not with surprise. I don't think there's a lot to add to the reduced form or structural setups from which they estimate these effects. But I do want to draw attention to that kind of very insightful analysis they do on potential viewers. And so, which I think is a really neat contribution here. And so in some other papers, or when I'm a TV audience guy, sometimes we only observe the total audience. But this paper, they observe the total audience, as well as the number of people coming. And so we could think of the green as the number of new players each period, and the red, the number of players leaving. And so what this data allows us to do is kind of answer questions about this matrix to the right. And so it allows us to look at how suspense may differentially affect current viewers versus potential viewers. And so they make, I think, the very grounded predictions that in a high suspense scenario, what you're doing is you're increasing the probability that someone's going to stay. And so you're decreasing the height of this red bar here. Whereas a low suspense scenario, you may be getting people are less likely to stay. And so they're less likely to stay. And this is like a really neat and important result that kind of their hard data work and modeling make possible. It also, I think, makes sense, which is important for empirical research. And so then I'll go to a few kind of food for thought and extensions. And so we'll go to the next slide. And so I really liked the paper. It was a lot of fun. But one of the things that had me was that win probabilities may not change drastically between rounds. And so this perfectly rational Bayesian updater is a big pill to swallow. And so would the analysis look different if viewers updated their beliefs every two or three rounds? And so I read a few of the other papers, and you see these massive changes in suspense and surprise in soccer. I mean, a goal in soccer is very important, but it just made me think like, well, what if we had bigger changes in suspense and surprise in a game like Counter-Strike? What if people really aren't kind of updating their beliefs every round, but really every couple rounds because they get lost in the game or something? So I thought that might be an interesting thing to think about. And secondly, and I know we didn't spend a ton of time on the recommendations or policy recommendations, but in the end, suspense and surprise explain kind of 2% of variation compared to 98% of the game level factors. And so this just tells me that we should be cautious with prescribing changes that are targeted at changing suspense and surprise, because they may also change competitiveness, which the latter may swamp the former. And so a few of the other papers look at kind of some game level effects like the number of star players or the set or depth in a tournament, and these things have very strong effects. So I think it would be cool to kind of look at, do some more comparisons between the suspense and surprise and other game level factors. And lastly, I have about a minute here. I'll just talk about some extensions. And so we can go to the last slide. And so the first is fandom. And the paper does mention fandom, and so it didn't get squeezed into the 45-minute talk, but it does mention fandom. And I think this is a natural extension. And so I'm a huge Green Bay Packer fan, and so positive and negative surprise definitely affect my consumption utility different, or at least that's how I think about it. And so positive versus negative surprise and suspense. And this may actually increase the relevance of surprise in the model. So surprise kind of doesn't have a strong significant effect, but if really what's going on is that it does, but it kind of the constant, the negative surprise is being offset by positive surprise, then we may actually see another interesting result here. And I kind of hypothesize that you can actually back out the fandom for individual chatters by looking at their Twitch channel history and their viewing history to classify them as kind of home fan, away fan, or just general Counter-Strike fan. And HLTV has some additional, has a lot of data around what channels people watch. And lastly, I'm an advertising guy, so what would be a discussion without bringing up advertising is that what is the interaction between advertising and suspense and surprise? And so this is really kind of two questions. My first question is Twitch placing advertisements when suspense or surprise is high or low? I don't know. I'm not even sure if they place ads during these events, but I think it would be cool to look at. And secondly, I did some exploring, and any individual can pay to get rid of someone else's ads on Twitch. And I thought this potentially leads itself to a cool idea where you observe for a baseline time period people's behavior. You randomly select some of them, and then you gift you basically remove ads for some of them and see how they respond. And you could always look at this in the context of suspense and surprise, because I imagine kind of an advertisement disrupts the flow of the game and does interact with suspense and surprise in some way, though I don't have any intelligible way of thinking about that. But yeah, that's it for me. I have some additional thoughts for you and happy to chat offline, but otherwise I had a lot of fun reading it. And I'd be lying if I said I've never played Counter-Strike before. And so this was a lot of fun to read. And so that's all I have for you.
Thanks a lot, Matt. This is very helpful. I'm not sure, I guess I don't have time to respond, but yeah, all these are very extremely helpful comments.
Yep. Okay, bye.
I have a quick question for the discussant or for Andrey. So game designers don't know this, or they do know that suspense and surprise matter?
That's a great question. I don't think there is. I'm sure there is appreciation that these things, suspense and surprise, matter a lot. I don't think they formulated it in such a way with the belief path and trying to back it from the data. But when they choose, and that's another application of this, is just thinking about game design rules, because then by designing the game, designing this belief martingale, you can affect what really happens. And that I think there was a bunch of changes in this Counter-Strike tournament rules, which at some point in the paper were thinking of trying to have the history of these rules and see how it affects the evolution of events. It just turned out to be slightly more tricky to tweak the model using this. But Absolutely, they have some idea that this is going on.
All right, thank you very much.
And so
by the way, that was me, Ron, here, so I didn't put my picture up. I'm sorry about that.
Perfect. Thanks, Ram. That's great. And I think, I mean, if we have a second, though, I meant to your comments. I think that
sorry,
anytime.
Andrey, I think we're already 3 minutes over. I'm sorry to cut you off here, but I think we're supposed to be starting the next session.
Yes, JP, you're on.
Okay, thanks. I was waiting for the timekeeper to do his or her duty, but I will do it then myself. All right. Sorry, Andrey, even being one of my former PhD students doesn't get you to borrow my time. All right, so let's see here. I need to share the screen very quickly here. A moment. Share tray. Okay. Your software, folks, this Teams thing slows down my computer. All right, let's see here. Can everyone see this? Andrey, since I had you there, can you see my slides?
Yes.
Yep.
Perfect. Okay, excellent. All right, then. Well, listen, thank you all. Thank you very much to the conference organizers for putting us on the program this year. It's been a long time since I've been at the BAS conference, and it's really nice to be back. Today, I'm going to talk to you about some co-authored work. One of my co-authors has been a longtime collaborator in the stream of work, Bart Bronnenberg, and Joonhwi Ju, another University of Chicago, former University of Chicago PhD student, now assistant professor at UT Dallas. This is broadly work related to brand preference formation. As you can see from the title here, we're going to do a case study of the craft beer industry, but our interest really isn't that much in learning about craft beer per se. Really, this is a more work in this broad vein of trying to understand how people form preferences in branded consumer goods industries. Let me give you a little backdrop on this paper and sort of the motivation. So some of you may be familiar with some of my past work with Bart. We have quite a few studies now in this stream of papers trying to understand why it is that CPG categories are so concentrated. So, you know, we have a handbook of economics chapter from last year or 2 years ago, where we actually look at all CPG categories in the US, and we find that on average, the 4-brand concentration ratio is almost 80%, which means for the typical CPG category, almost 80% of the sales volume, and you get more or less the same result if you use dollars, is literally driven by 4 brands. And truthfully, in many of these categories, the top 2 brands really do the lion's share of the work. Now, the other interesting fact is not just about documenting this concentration, but understanding sort of how persistent these market structures are. And it turns out that if you look at local leaders in the 1950s and 60s, those same leaders are still dominant, at least in the early to mid 2000s. And that more interestingly, if you look across cities in the US, that different brands tended to dominate, but they remain persistently dominant, sometimes not just over the second half of the 20th century, but in a series of case studies, Bart and I showed that sometimes that dominance persisted all the way back since the 1800s. So the bottom line is we got this very robust snapshot of consumer packaged goods categories and their market structures, which is really summarized as a small number of very dominant brands controlling the lion's share of sales and volume, and that the dominance of these brands has persisted for at least half a century, and in some cases more than a century. And that really segues into the stylized fact that motivated this research, which was all of a sudden, and it's not just a beer phenomenon, but in many large CPG categories, all of a sudden in the last 10 to 15 years, we started to see the emergence of new, smaller brands. And the common thread of these brands is they tend to be described as craft brands, these more artisanal, locally sourced, you know, things that are considered sort of higher quality in that hipster sense of higher quality. And just to give you a sense, in 2016, the top 20 CPGs saw flat sales, while smaller firms were averaging 3% annual growth. And that was after 4 years, 2011 to 15, in which large CPG companies overall lost almost $18 billion worth of market share to craft manufacturers specifically. And more recently, if we look in 2018, if you look at the 16,000, you take a set There's a specific set of 16,000 smaller CPG manufacturers. They captured 2 percentage points of all of CPG just in 2017. That's $2 billion, which means they now collectively account, these 16,000 smaller firms, for almost 20% of US sales. And if we meanwhile take the sales of the 16 largest CPG firms over that same period, they collectively lost 3 percentage points. So for those of you familiar with the consumer goods industry, losing 3 percentage points of market share is pretty catastrophic. So this is a really big disruption to a market structure that Bart and I had more or less described as like being persistent, and all of a sudden things have changed. And the leading explanation for this change, if we defer to marketing experts and into the trade press, seems to be millennials. So Pew Research defines a millennial as someone born between 1981 and 2000, but the broad consensus seems to be that millennials are the ones driving this change. And why is this? Because there's many different surveys have shown that millennials are more likely to self-report liking craft brands better than the recognized national brands, that millennials think these are better products, right? And most importantly, they're more likely to buy them. Millennials allocate a much bigger share of their expenditure shares of their budgets to these craft alternatives. And this has given rise to what we're calling the generational share gap, which is essentially that millennials are the main consumers of these emerging artisanal craft brands. And by generational share gap, we literally mean, and I'll document this momentarily, that millennials are not only more likely to buy craft brands, but also seem to be disproportionately driving that growth. And so our paper, and this is kind of like where it gets into now, what's the question we're tackling in this paper? Well, frankly, what we're doing is essentially a positive analysis. And I know that 99% of the papers on the program in the last few days have really been tackling more normative issues, but we're going to take a step back and ask a more positive related question. And to do so, we're going to challenge this millennial tastes argument that essentially argues that millennials are fundamentally different from other generations, that they have heterogeneous preferences, these intrinsic, time-invariant preferences. And let's be honest, that's actually sort of the default explanation we use in a lot of our brand choice work. You know, we have random coefficients, we put brand fixed effects into the model, or random effects, and we just sort of assume that consumers are intrinsically and persistently different. And that's fine for a lot of our work, where the brand intercept, if you will, is essentially nothing more than a nuisance parameter. But when we're trying to understand preferences, and to this end, I'm really appealing to a very long stream of University of Chicago style thought, there's been a lot of debate going back to the 70s about how useful it is in economics to simply call it heterogeneous preferences. So I quote Stigler and Becker in their famous De Gustibus Non Disputandum, that tastes neither change capriciously nor differ importantly between people. Tastes will be there next year too, and are the same to all men. And essentially, this is an alternative explanation that we're going to use. Instead of trying to explain everything as just persistent and inexplicable heterogeneity, we're going to use a neoclassical consumption capital theory, a price theoretic approach. And what we're going to do is try and offer an alternative explanation that the differences in behaviors we're observing between generations are not due to persistently and inexplicably different preferences, but rather it's differences in consumption capital stocks. That it's no small coincidence that millennials turned of age exactly at the moment that we're starting to see a much higher influx of craft brands, and not just in any particular category, but across the board. And so here you have this new generation of adults with relatively malleable and still unformed preferences, who are simply given access to more variety than their older generation counterparts. And so our alternative explanation to the heterogeneous preferences, or the generational preferences theory, is that millennials have less consumption capital than older generations and are therefore more likely to try new brands and have a much higher availability of new brands to try. So to that end, now that brings us into our case study. Why pick the craft beer specifically? Well, for those of you who know me and Bart, you'd probably then not be surprised that field research played a big role in this, and the ability to drink beer and drink many different kinds of beer in the spirit of research, that's right, I did air quotes, is certainly an appealing feature. But realistically, there's a whole bunch of really nice substantive reasons why craft beers is a good case study for this particular question. Number one, since the 1960s, this is a category that really has been dominated by a small number of companies. In fact, Anheuser-Busch and Miller, since the 1950s and 60s, has essentially controlled almost over 90% of beer volume and making one specific kind of beer, pale lagers. And so three things, I'm going to try and roughly call these exogenous things, have really facilitated the new entry of craft beers in the beer industry. And two of them are sort of idiosyncratic to beer. One of them is more broadly relevant to CPG. But the first thing that happened in beer is that in 1979, President Carter legalized home brewing. This wasn't because of a beer lobby. It was part of another much broader initiative to deregulate lots of industries in the US, a pattern that continued under the Reagan administration. And that gives us a really nice point of departure. 1979 is the year it became legal for people to make home brews. And then shortly thereafter, most of the states started passing their own laws based on that deregulation to allow brew pubs, which meant that not only could you make home brew, but you could build your own small establishment and sell that home brew direct to consumers. And that really gives us a nice time frame for thinking about, well, when did craft beers become quote unquote relevant? And to the extent that many people grew up with zero craft beer, like baby boomers and the greatest generation, et cetera, that's kind of an exogenous phenomenon. Second big feature of this industry is just the broad rise of the internet. This is obviously not something that's specific to beer, but the fact that companies could go online and advertise, especially by the early 2000s, and get broad awareness much more cheaply than through the traditional means, which would have been radio and TV. And of course, more recently, the ability to distribute and sell craft products online. That may not actually be that helpful for the beer industry, but for those of you who are interested, right now, currently, the state of Illinois is debating legalizing the sale of craft brews and brew pub beers via the internet. But the internet has just created a huge catalyst for entry by lowering the traditional costs of entry into branded goods industries. And the third major phenomenon here is organizational. It was the collection of small informal brewing associations merged together and created the Brewer Association of America in 2005. And that really is, in some sense, a big takeoff point for this case study, because that led to the formal, nationally recognized designation and definition of what constitutes a craft beer and who is allowed to put craft on the front of their bottles. So let me now talk a little bit about our this generational share gap in beer. The U.S. craft beer segment grew pretty fast. Between 2010 and 19, we saw like approximately $20 billion in growth just in craft beer sales alone. And I should qualify, this is the take-home market. This is not even including the tap market in restaurants and bars. And according to the Brewer Association, 50% of millennials drink craft beer versus only 36% of the older generations. And 43% of millennials self-report that craft beer tastes better than national brands versus about 30% of baby boomers. So you can see that this pattern of millennials disproportionately drinking and liking craft beer is consistent with that broader millennial trend across lots of other craft products and other CPGs. And according to the 2018 Nielsen data, millennial expenditure share for craft beer is literally a third of their budget versus only 20% for baby boomers. So again, you can see this millennial effect is clearly present in our craft beer case study. And that brings us to our research goals now, which is to test for the mechanism that might be causing this generational share gap. And we're going to boil this down to two competing theories: the intrinsically different taste hypothesis, which is essentially one of there being a fundamental generational taste, and the theory of consumption capital formation across generations, or between generations, if you will, which is that it's not so much that generations have their own intrinsic tastes, but generations have grown up with different brand experiences and product experiences, including in the beer category. So our mode of operation here is going to be to estimate a demand model with consumption capital formation. That's going to be part of the structure of this demand model, so that we can then estimate and test a causal effect of availability history on consumer demand. And then the goal of this model is going to be able to conduct a counterfactual where we ask the question, well, broadly, we investigate how important are intrinsic preferences versus consumption capital in explaining that generational share gap. And to that end, we're going to run the counterfactual. Imagine that millennials kept their preferences to whatever those are, but just simply were born in the same year as a baby boomer, and therefore had he grown up with the same set of availabilities and therefore experiences as a baby boomer. And the question is, if we just gave the millennial a baby boomer life experience, would they still shop differentially from a baby boomer? Now, some of you are already worried here. Well, wait a minute. How can you get a causal effect of availability and variety on demand when we all know that in equilibrium, variety is an equilibrium outcome, right? I mean, that this could just as very well have causality going the other way. And so our empirical strategy is going to be as follows. First, we collected manually a census of U.S. craft beers and brewers by city all the way back to 1979. Second, we're going to match this census with Nielsen panel shopping data on household purchases, where I underline the word panel because using the panel structure is going to help us some of the way. We can include things like market fixed effects to get rid of persistent sources of selection. In other words, we all know that it's not by pure chance that Portland, Oregon has lots of craft beer, and meanwhile, a big city in Tennessee might not have nearly as much craft beer, right? We'll be able to control for those persistent sources of selection. And then finally, for the naysayers in the audience who are still worried about potential differential trends, we're going to use an instrumental variables strategy to try and come up with two instruments that we think plausibly generate exogenous variation in availability. The first one is local population. That's not a new story. Population and population growth have been shown to affect industrial entry across a large number of case studies in the US, including the beer industry. And the second instrument we're going to look at is time since local legalization of brew pubs to give us a sense of differences in the point of diffusion of craft beers and the amount of time that's elapsed since they were even permissible across regions. But the bottom line is to try and use differences across markets in the evolution of craft brewers to try and extract the exogenous component of that and use that to help us test for and measure an effect of availability on demand. And our findings here, I'll summarize them really briefly, and then we'll get into details. We're going to start with some reduced form evidence. I'm going to show you that generation alone cannot account for the generational share cap. I'm going to show you that the effect of current and historic availability on demand is big, it's significant, both economically and statistically. And then using our structural evidence, I'm going to try and convince you that 85% of the generational share gap can be attributed to consumption capital and differences in availability when various generations became of age. And then a small forecasting exercise, I'll call it a poor man's forecasting exercise, would suggest that this fragmentation we're seeing, at least in beer, will continue over the next 10 years. And we're predicting a craft beer share of almost 30% of the market by 2030, which again is a massive disruption to the market structures that we've seen in CPG throughout the 20th century and well into the beginning of the 21st century. And of course, if you're looking for a managerial implication, I know that normative tends to be the norm. I think this is just one more piece of evidence on the critical importance of marketing to consumers when they're young, and recognize the net present value, the discounted stream of benefits that accrue to marketers when they invest in marketing to young consumers. All right, so I can't see the audience here. I just see Andrey smiling at me whenever I shift over here, but I just want to make sure here I haven't missed anyone. Okay, feel free to interrupt me if you have a question. If not, I'll continue.
Just a quick comment here about.
Surely, Ram.
Yeah, so in Dallas, what people have done is at SMU, which is a private school here, beer companies have been supplying free beer to the fraternities. When they first come in. This is for freshmen, when they're 18 or whatever. The idea is exactly what you just said. You catch them young. Yep. They're just coming drinking age. Give them free beer. They get hooked on your brand. Hooked may be a strong word, but they get used to your brand, and then you're in good shape. And as you know, in Chicago, they used to distribute free cigarettes on Michigan Avenue.
Perfect.
Up until the 80s.
So Ram, I just want to clarify. I'm not going to design marketing policies today. I agree with all of that, and I think that firms do try and market to the young. I was just saying that an implication of our work would be to do stuff like that, so I agree with that, but I just want to make sure we're clear. I'm not going to simulate marketing policies to the young. The rest of my talk is going to be the positive analysis of preferences rather than the normative implications.
Okay, thanks.
Cool. So I think I'll just quickly talk about the data. I don't think I'm going to say much about the Kilt shopping panel because most of the folks in this audience should be all too familiar with the Nielsen and the IRI style data sets, but we are going to use Nielsen panel data from 2004 to 2018. We have over 80,000 beer buying households, 2.6 million transactions, thousands of UPCs. This is what makes that market structure so impressive, because you have thousands of UPCs, and yet most of them are really in that sort of right tail of these tiny little share products with a few key brands generating most of the sales. And we're going to collapse things to the annual level. We're going to look at each household's annual share of beer purchased that's craft as opposed to macro brewed, and we have 270,000 household years. I think for the purposes of today's study, the more important thing is what we're going to do with these households. We're going to classify each household into a generation based on the oldest household member who's reported in the panel survey, which means I'm just going to then use Pew Research's generational definitions to make that classification. So you got the millennials here are the key. People born between 81 and 96. I think I had 2000 on an earlier slide, so I better be careful with the consistency of my slides here. And then I think we're just sort of arbitrarily, because the baby boomer generation is still the largest fraction of adults right now, we'll just probably I'm going to compare millennials largely to baby boomers who were born, like between 46 and 64. In our data set, by 2018, millennials represent almost 20% of households. Like I said, baby boomers are still the largest segment at 50%. And then for the remainder of our analysis, if I don't always point it out, I just want you to know that I will residualize most of our analyses on other socioeconomic status, like income, years of education, and household size, just because there are some differences between generations in these other demographics, and we want to make sure that we're really focusing on the generational differences and not other incidental demographic factors. Here's the more interesting part of the data, which is this beer census that we created. I really would be not doing justice without really singling out Joonhwi, who found and put together this incredible database by hand by going to dozens of sources. It's sort of working on this again brought back some fond and some not so fond memories of piecing together brand histories with Bart back in 2004 and 2003. But the result of this very large effort, and I'd say it was like almost a year of data collection, was to be able to take all 36,000 UPCs that consumers buy in the home scan panel and to be able to determine which of these at the UPC level are actually craft beers and satisfy the craft designation. And also we have a bunch of attributes about them as well. And this all came from large sources like ratebeer.com, the Brewers Association, etc. What we also have, though, in this data collection is information about the brewers themselves, including where they located and when they entered, all the way back to 1979, which is going to be the basis for how we learn about availability. And then getting into those two instruments for beer, the Scantrack populations we have going back to 1969 come from a cancer research program. And then we have state-level brewpub legalization, thanks to Ken Elzinga and his co-authors, who very kindly shared these. You would think this would be easy stuff to find, but believe it or not, LexisNexis and other legal libraries are remarkably difficult to query because of terminology. But the bottom line is we just got all of this timing information directly from Elzinga, which saved us an enormous amount of headaches trying to do this ourselves. So just a quick summary of the data. Here you can see I've got the solid line represents the share of beer sales in the US according to the Nielsen home scan panel. That's share of volume, and then dotted is share of revenues. You can see the gap here. This just reflects the fact that on average, craft beers tend to be more expensive. But you can see either way you slice it, there's been some pretty steady growth since 2004 to 16. So by 2004, I would hardly call these a small niche. They still represented 5% of the category. But in just a few short years, an industry dominated by Anheuser-Busch and Miller suddenly found itself losing, over almost 12% of the volume and 20% of dollar sales to this craft competitor, and this trend doesn't seem to be going away anytime soon. Here's the thing that we're more interested in, which is the generational share gap itself. What I've done here is just look at the average across household years for households in each of the generations, and the share of their beer. This is done in volume. You could do something similar with dollars spent, but their share that's craft. The diamonds here are the residualized shares, where I residualized on socioeconomic status. You get the point here. You can see that even Gen X, which had craft beers even when they were a little bit younger, right, is not buying nearly as much craft beer as the millennial generation. And that even after residualizing, well, the gap shrinks a little bit. This is still a statistically and economically significant difference, right? So the bottom line is, even after residualizing, you can see that, you know, millennials are buying approximately 12 or 13% craft beer. In the raw data, it's almost like 18% compared to much lower shares than the other generations. And moreover, the other generations don't look all that different from one another. You know, we probably wouldn't be talking about a generational share gap, but for the millennials. Yes? I'm hearing a comment. Oh, okay, just some background filter. Okay. So here's the key variable we're going to construct for our analysis. This is the availability measure we're going to use. So our thinking about this was, well, what does it mean for somebody to be considering craft beer? Well, to some extent, we'd be interested in measures of awareness and availability. So the way we worked on this was to think about local entrepreneurship. It's not just that you see a craft beer on your shelf that makes you buy a craft beer. It's that there's a craft beer presence in the place you live. You know, Ram kind of alluded a moment ago to the fact that local brewers are giving away free beer to fraternities, for example. Well, another way people get acquainted with local brewers is there's usually a brew pub, right? There's signage, right? There's buzz about it. Local stores will carry these and will often promote some of the localness of these breweries. So what we're going to do then is calculate, or from our census, the total number of brewers in a given market M in year T, right? These are local brewers. So you literally have a brewing operation that satisfies the craft designation in your market that year. And then we're going to normalize that by the total number of brewers that people are probably familiar with, which is going to be the combination of your local craft breweries, and then the macro brewers. And we're going to assume that everyone knows the macro brewers. These macro brewers are not very large in number. I think they sort of averaged out at around 19. There's 19 of them right now, and that's been true since about 2012. Some of you probably think, wait, how's that possible? And the answer is a lot of macro brewers shut their operations by the early 80s, and then there was a lot of consolidation prior to our sample period. So we're going to normalize this thing, but the right way to think of this approximately is what share of local beer brewing awareness is driven by, or represented by, craft. And here I can just show you to give you a sense of the variation in our data, going all the way back to deregulation, then forwards to the 2018. I have the distribution of availability across markets and time. And what you can see is there's a lot of variability. There are markets that took a long time to get any craft breweries, right? This is these whiskers here are the centered 95% intervals. And you can see here that over time the mean increased, but so did the dispersion. We see the dispersion widening and then contracting again. So there are a lot of differential trends in the evolution of availability across market. And then just to give you a sense of that, of why we think that could be an alternative explanation to the popular it's all heterogeneity, in this case, generational heterogeneity. Well, you can see here that different generations had different access to craft brands when the oldest person in the household turned 21 years old. Mechanically, these older generations didn't have any craft brewers around, but even compared to Gen X, millennials on average, and for the most part, just had a lot more craft breweries around at the time you turn 21 and start buying beer. And I know there's somebody in the audience who's going to be very proud of their fake ID, but we're going to use 21 as our starting point because we're going to assume the modal household obeyed the law, which probably sounds like saying the modal household didn't live in a college dorm. Anyhow, no need to get into that. So now what I'm going to do is take these data, I'm going to take that generational share gap, and I'm going to talk a little bit about our economic model that we're going to use to try and parse generational intrinsic heterogeneity versus consumption capital. So I'm just going to steal the model that Bart and I used in our work with Matt Jenskow a few years ago, where we were looking at migration in brand preferences and brand capital. And we're going to use that same idea to try and parse consumption capital in this case study. So Y here on the left-hand side just represent household H's share of craft beer in year T. And our model broadly says that there's two kinds of things that drive your share of craft beer in a given year. Some of that we're going to call intrinsic tastes, which has to do with just things that are specific to you as a household, most notably your generation, not to mention stuff going on at the point of sale, in this case study, most notably availability, versus consumption capital, where consumption capital, just like in our other paper, is just going to be the depreciated result of all of your past experiences at all past ages, although we're going to start this off at 20. We're going to initialize this at age 21. And if you do a little playing around with the model, it's pretty straightforward to show that our consumption capital model has a consumption capital following a pretty simple and generic law of motion, that over time you can see that the capital stock is evolving. You can think of this here as each period based on how much consumption you do. That creates a gross investment into your consumption capital. And then you have what's ever left after depreciation of your previously existing consumption capital up to that point. And the model also implies a time-varying depreciation rate. This is a little bit functional form-esque, although we're going to estimate the parameter delta momentarily so that this will be somewhat data-driven. And to the extent this functional form kind of mechanically implies that when you're older, your consumption capital is more persistent, that is, of course, based on data in and of itself. There's an enormous literature showing that as people age, they're less likely to switch, which means that you become more and more persistent. And our theory of this persistence in older people being less likely to switch, whether it's brands or some other behavior, is just a reflection of the deceleration in the rate of depreciation of their consumption capital. So from this, we're going to derive an empirical specification, which is to try and predict the conditional mean share. And that conditional mean is going to have two big components to it. This first piece here, which is all the intrinsic stuff, these are things that are like the preferences, and then we're going to load into this a generational specific set of preferences. And then separate from generational preferences is we're going to allow for a time varying part of your preferences, an evolution, if you will, which is essentially, this is the consumption capital stock, right? And if you stare at this for a second, you could see, wow, this is actually, at first glance, a relatively straightforward linear distributed lag model over all the historic availabilities, right? From all the way back to your 21, but it's also kind of an inconvenient distributed lag because the parameters in this thing are age specific. So this would be a very high dimensional model to estimate even in reduced form. So that's why the structural approach, using that consumption capital, is just a way of parsimoniously summarizing the collective effect of all of your past experiences on your current shopping behavior. Now, obviously, this is where things get a little hairy. What about the endogeneity of availability? I think that's a very reasonable question. If I was in the audience, I would certainly ask about it. Well, at first glance, we have lots of reasons to think it might not be a concern. The founder and president of the Brewers Associated, Charlie Papazian, actually said over 90% of small brewers that he meets have their roots in home brewing. So this is another sort of idiosyncrasy of beer, that most of the small craft beers started off by someone who was more of a zealot, who just liked to make their own homebrew and eventually decided to sell it. But you could make a logical case that the reason the brewer emerged in the location they did and at the time they did was driven more by a zealotry over beer and brewing than it was by a desire to create a commercial enterprise. That said, I mean, I'm not saying there's no endogeneity. This is just an argument there might not be, but you could still argue that even if you're a zealot, or you're a hipster or an aficionado, it may not be totally random why it is that you were able to commercialize when you did. And so what are we going to do? We're going to include market fixed effects. So at a minimum, differences in availability between markets. This will be robust to persistent self-selection. But on top of that, we have these instruments. We're going to introduce some auxiliary moment conditions, including the ones inspired by the model I showed you a moment ago. And those two sets of moment conditions are going to be historic population, which past research has shown is a driver of entry in the beer category specifically. So several people have demonstrated that population is a very good, and we find the same, a strong predictor of the number of industrial competitors in the market. And we're also going to use years since local brew pub legalization. Are these powerful as instruments? The answer is absolutely. Imagine a linear IV estimator where in the first stage we run a regression of availability on these excluded instruments. We're going to use the current in every fifth lag of population. If we run that in the first stage, including market fixed effects, socioeconomic status, and we'll cluster our standard errors, we still get an incremental F statistic of over 100. If on top of this we add years since local brew pub legalization, we get an incremental F stat of 312. So as I said, given the past literature I mentioned up here, not surprising that these things have a lot of power. The hard part here is I'm never going to be able to test and confirm that our moment condition at the top of the slide is 100% valid. But for whatever it's worth, some placebo checks here suggest that at a minimum, there's no evidence that our instruments are systematically higher in markets that already have high market shares of craft or in markets where there's already a lot of craft brewers. So at a minimum, as a placebo check on the moment, it looks like, if anything, the instruments tend to be slightly lower in markets that have high craft share and lower in markets that have a lot of craft brewer presence.
JP, quick question.
Yes, indeed.
In this case, why not to use the same instruments you used with Bart and Matt in the migration paper? Why not use just people migrating from location to location with different...
Because I don't observe people's migration. Remember, for that paper, we had to run a separate survey in 2008. And remember that the home scan is a rolling panel. So you would literally need to run this almost every year to be able to get migration histories on everyone. Because remember, I'm using 2004 to 2018. So we did do a small check where we used the migration data and we did some stuff there. It was a nice check of, I'm not going to get into it now because I only have 5 minutes left in my talk here. But the simple answer, Andrey, is we just don't have enough data. We would have to have run these surveys every year almost back to 2004. Okay. All right. So the first thing I'm going to do is estimate a reduced form version of the model. I should put quotations around that because it's quasi a reduced form. The first specification, in fact, is a reduced form. Imagine I took the model I talked about a moment ago and I restricted alpha, that weight parameter, to be exactly equal to 1, which would say there is no consumption capital, or if there is, consumption capital has no role on your preferences. And in that case, the only thing that matters are going to be socioeconomic status and then generation specifically. And when I run that regression, I get a really big millennial effect, right? I mean, the average millennial effect is almost 17 percentage points. And look, comparatively, even Gen X is like 10 percentage points lower. And then, of course, when we get into these other generations, we're pretty small shares. So this is like the huge raw generational share gap that we started off with about 20 minutes ago. And look what happens, forget about IVs for a moment, when I just condition on availability. I'm going to include this is why I say quasi-reduced form. I'm not going to estimate all the lags, but if I just include availability, and the availability when you're 21, right, you can see that these coefficient estimates get much smaller. They lose over half their magnitude. So the generational share gap collapses, right? It doesn't go away, but it gets compressed, and generational differences shrink considerably, right? And these two things are big and significant. So now what I'm going to do is move over to the third and fourth columns, where I'm going to use those auxiliary moments. Can't say the word auxiliary all of a sudden. And you can see here that, again, even with our IVs, you can see that these availability effects are large. And most importantly, the historic one is significant, right? And this is not the entire experience history. This is just one measure of differences in experience, what was available when you were 21 years old. But just conditioning on the second term, look what it does to the generational share gap. The point estimate shrinks by over half. I suppose it's true that I can't reject that this point estimate here is like, you know, is a little bit bigger than that, but I mean, it's still significantly different here. This doesn't say there's no generational effect, mind you, but it does tell us that the generational differences are considerably smaller, even after I just condition on a little bit of history. Now I turn to the structural model where I try and use that capital stock formation process to control for the entire history. And so you could still compare this very first column to this very last column, and you can see that the generational share gap has almost completely disappeared here. Again, I can't reject that this point estimate is as big as 5 percentage points, but even at 5 percentage points, this doesn't even come close to explaining the generational differences in shopping behavior. Besides showing you that including the entire experience history shrinks and pretty much eliminates, subject to standard error interpretations, but almost eliminates the generational differences, our structural parameters are significant and interesting. Look at this one here, alpha. Alpha is almost exactly equal to half. What that says is, according to the data, half of your shopping behavior is based on what's going on at the point of sale right now. Half of it, the other half, is coming from what happened to you in the past, which is actually not very different from the conclusion we got in that earlier paper on brand history and migration. But what's remarkable about this is that even though half of your behavior is about the point of sale right now, it looks like generational differences in those point of sale effects are not the driving factor. There are other socioeconomic variables that predict differences, and in the interest of time, I won't get into them, but there are good reasons not to be surprised that education and income are very strong predictors of who intrinsically prefers craft beer. You know, people who have knowledge and are educated like artisanal stuff, people who have more money can afford a price premium, etc. But the bottom line here is that whatever is driving that other half of shopping behavior, it ain't generational. So, you know, like I said, this is something I'll just defer to the paper. We did do some importance. We looked at importance weights on these different socioeconomic factors, and generation is doing a very small part of explaining behavioral differences. Meanwhile, there are other socioeconomic variables that are explaining a lot. And I thought this was a nice sanity check. It's not that there's no heterogeneity in behavior, even absent experiential differences. It's just this generational effect that we're obsessed with in the trade press might be a little too simple of an explanation. And, you know, according to our estimates here, I've got that depreciation rate in brand capital. This is based on our estimate of delta. And you can see here.
Sorry to interrupt. You have 5 minutes left.
I have 40 minutes.
No, I mean, 5 minutes left.
Yeah, no problems. Yeah, I hope to be done in less than that. Thank you for the heads up. Yeah. All I'm showing you here is that that consumption capital depreciation rate. And you can see that all but the youngest millennials, who mechanically, because of the model, are implied to have very fast depreciation. You can see that even before you become, even before we get out of the millennial generation, estimated consumption capital is really, really persistent, right? That there's very little depreciation except for our earliest adults in our sample. So now we can get to the counterfactuals. This is getting back to the key question. Here's what I'm going to do with the model estimates, is we're going to ask the question, well, what is the generational share gap? So we're going to use the model to calculate the conditional expected share for a household based on their traits, which includes generation, and given their age and given the availabilities and the entire history of availabilities. And we're then going to compare that for our millennials in our data. And we're going to then, this is essentially the moment we observe for millennials in the data, and we're going to take that, or the predicted moment we observe, we're going to then calculate a counterfactual moment which says, what if the millennials became baby boomers? So we're going to hold everything else the same, but we're going to turn you into a baby boomer, which means you inherit the persistently different tastes of baby boomers. And we're also going to assume you were born at the same time as a baby boomer so that you mechanically experience all the same availabilities of craft beer that you would have had you been a baby boomer. So that is our generational share gap according to the model. And we're going to then compare that to what we'll call the experience share gap, which is kind of the same exercise, except the counterfactual moment of interest. We're going to let you retain your generational preferences, and we're only going to say what would happen if you had the same experiences. And this is sort of the key statistic of interest at the bottom here. We'll call this the experience share of the generational share gap, which essentially says what fraction of the generational share gap is purely driven by differences in experiences. And we calculate that with our within our data, and whatever, a big hop, skip, and a jump, and we get to 85%. That's kind of the punchline here, is that 85% of these generational differences seem to be due to experiences and not some intrinsic difference between generations. And this is why, when Ram and I were chatting earlier on at the start about free samples and marketing the young, I think that is a really crucial takeaway if you're looking for normative implications, that hitting people when they're young has a lifetime potential benefit. And then our second counterfactual of interest is a poor man's counterfactual, where we ask what will happen over the next 10 years. The word poor man here reflecting the fact that we're not going to simulate the dynamic entry and exit of brewers. Instead, what we're going to do is just fit an AR1. We tried some higher order models, but we're going to fit a stochastic process to the entry rate of craft brewers by market. And what we're going to do is use that AR1 to extrapolate after 2018, which is our last year of the data. And you can see here this dashed line here, that's where we allow the number of brewers to evolve, is our forecast on the craft market share. And you can see that we're predicting approximately 28 percentage points. So you can see here, our prediction is that, well, there's going to be a slowdown. And the slowdown's coming from the fact that older generations do eventually start drinking some craft beer. Now, either that or they die off and are replaced by new beer drinkers. But some of the growth will slow down. I suppose we should probably keep projecting forward. It'd be interesting to see where it sort of settles. Is there kind of a steady state in this model? But at any rate, it looks like the category we predict is going to continue to fragment. So with that, let me summarize really briefly here. I think that the key thing we wanted to convince you of is that contrary to this established wisdom in the marketing industry, we attribute most of the generational share gap to these historic differences in experiences. In other words, our prediction is that millennials would shop more or less exactly like baby boomers had it not been for differences in availability. And we think this is an important detail because it's going to help us understand this recent fragmentation. Another thing which I think is an important takeaway from all of this is that when we're trying to understand brand preference formation, it kind of suggests that the supply side plays a role here. I mean, to the extent that we really want to understand thoroughly how preferences were formed in this industry, we actually need to think about the dynamic entry process on the supply side. Now, we've treated entry in reduced form, if you will, on the supply side. We've acknowledged it. We tried to instrument for the endogenous components of it, but seems to suggest that entry dynamics are an important role in understanding the shaping of differences in preferences, and that the historic evolution of availability seems to be explaining a lot of the behavioral differences between generations. And then the third point about market structure, that we continue to see fragmentation. An interesting research direction here would be to look at the ongoing mergers and acquisitions in the industry to ask the question, are we going to see a fragmentation at the brewing level, at the manufacturer level, or is M&A going to offset of this, that basically Anheuser-Busch is going to keep acquiring all of these craft brands and they'll see more fragmentation across their brand portfolio, but they're still going to be owning most of the category? And I think this is an interesting question because of all of the recent IO literature suggesting that if anything, concentration's growing over time with huge incumbency advantages since the 1990s. Perhaps craft beers and CPGs are an exception. And our prediction, although we haven't investigated, is this all will generalize nicely to other CPGs, Greek yogurts, other online direct-to-consumer goods, largely because the internet has created a big disruption to the traditional barriers to entry, and it's not nearly as expensive as it used to be to invest in generating awareness for a new brand. All right, so with that, I will say thank you. I also have a bit of a strange bait and switch I'm going to pull on you here. Ella Honka, who is our scheduled discussant, has recently been injured and is unable to join us. She just let us know about a half hour before this talk. So what I'm going to do is put up her slides, and you're going to have to bear with me because I'm working on my interpretation of her slides, but I wanted to make sure we went through her comments. So before I do that, I just wanted to pause in case I had a question or comment that's from the audience. I speak at a pinball speed, which may deter some from wanting to ask a question, but I'm not seeing anyone.
JP, yep. I got a couple of one comment and a question. So since Ella is not here, I'm not taking her time. So the first one is it's a clarification. Across the generations, are income and educational, are there large differences? And I know that it shouldn't matter theoretically, but but maybe there's something there. That's one question. That's just on the data. The other one, it seems to me, since you've done a lot of this work, you could think about whether there is are there higher switching costs for some categories? I think beer and cigarettes, they're very high switch. So the consumption capital persistence is going to be much greater, as is going to be in ketchup, because ketchup is introduced to children at the age of 2 or 3. So I'm wondering if you could think about that or comment on that, both questions, and I'm going to put me on silent now.
Did we lose JP?
I think maybe JP's gone.
Okay.
Maybe something happened to him when he was doing that Ella thing, you know? That's my guess, because I didn't get any.
Well,
looks like he's just disappeared.
it's not always nice to his former students.
Maybe Bart or Joonhwi can comment on these things too.
Yes, I'm happy to comment, Ram. Can you briefly summarize the question again?
Yeah. The first one has to do.
Sorry, can you guys hear me now? Hello?
Yeah,
okay, I don't know. For some reason, my earphone's disconnected. Sorry about that. Okay. Ram, I was just in what I was said, but I was on mute. Is that the generation that we do residualize every model on socioeconomic status? Okay. And so we do that. We do control for that in all of the specifications. But more importantly, in the paper, we do describe differences between generations. And remarkably, and remember, this is all pre-COVID, right? Millennials are not that different from older generations. They don't have an income disadvantage. So there is a short discussion in the paper about those differences, but the key is for the models, everything is conditional on those differences anyhow. So to the extent, and that's part of why we do this, if there really was a huge income gap between millennials and baby boomers, we'd want to make sure that wasn't so spuriously creating a generational difference.
Sure.
Now, the second question you had was about differences across categories and generalizability, and you mentioned people eat ketchup when they're little kids. I think that the big change here would be that age 21. We picked the age 21 because that is when people are legally allowed to buy beer, but there's nothing that prevents us from saying all the way back to when you were like whatever age, right? So we could potentially have set that thing to age equal to 0 or age equal to 1 year old.
No, what I'm saying is you may be able to bring a little bit more into the analysis by saying the consumption capital from the previous generation is transferred to the next generation in the case of ketchup, but not in the case of beer. That's what I was trying to say.
I see, yeah.
You could also think about consumption capital being transferred from generation to generation like wealth transfers, you know?
That's fine, and that would be captured. I mean, the model we have here would certainly be able to capture that. What I think is more about an empirical regularity. If what you're saying is true, that we might not see as much of a change, or at a minimum, it might not kick in as quickly, right? That a young person might not be as quick to try new brands in those categories than they would in beer. But the fact is, there is a generational share gap in CPGs. It's been documented in lots of other categories, like Greek yogurt's a nice example. You know that you see millennials are much more likely to buy Greek yogurts than older generations, for example. And so all of these things are suggestive that there's more going on outside of the beer context. But I couldn't comment, having not done those case studies, if what you're saying is correct, namely maybe craft beer is an outlier in terms of how quickly the millennial generation latched onto them. So
thank you.
Yeah, lots of room for additional work. We've got a few minutes here. If you guys don't mind, I'm going to try and share Ella's slides here. Somebody could just let me know if you're able to see them right now. I know that Teams doesn't always cooperate. Are you guys able to see Ella's slides?
Nope.
How about now?
Not it.
No.
So what I'm going to do here, give me 1 second. I'm just going to stop sharing and start sharing again. We got to do a little trial and error here. To the UTD folks, I highly recommend using Zoom. Let's see, we'll try this again.
Maybe a reflection of your consumption capital.
Yeah, well, it's the damaging effects of state dependence. Can you see it now?
Yes.
Perfect. Okay, so Ella provided a really nice and thoughtful discussion. She was going to do a summary of what sort of a summary slide here, but I think that hopefully that what we did was relatively clear, because this is not a very high tech in terms of math and equations type project. She had a number of nice things to say about the execution and nature of the topic. So thank you very much, Ella. I appreciate that. I'm sure my co-authors do too. Now let's get into the butt slides, right? Some comments. So I think Ella raised a bunch of really interesting questions here. Some of this is somewhat related, is not identical, but related to some of Ram's comments and thoughts. But Ella wanted to know a little bit about what these intrinsic preferences are, what are initial preferences, and where do they come from? After all, we do find that millennials, that even if absent the generation, we still see behavioral differences of young people. Where do they come from? And I think that was kind of what what Ram and I were discussing a moment ago. Like, it's possible that even a millennial turning 21 years old has inherited some brand preferences from their parents, which is why they're not buying 100% craft beer or 50% craft beer for that matter, although there's obviously price effects, etc. But for this paper, I think the right way to think about what we've done is that we are loading a bunch of stuff into what I call intrinsic preference, but we haven't said anything about where those intrinsic preferences came from. What the paper is asking is, net of persistent differences between generations, does experience explain differences in behavior? And to that, I think we have an overwhelming answer, yes. But I think there's a lot of interesting research that should be done, really digging into, when people start buying, what are the drivers? And even if I haven't formed my own capital, as Ram suggested, I may have inherited some capital from my parents. And we tried to answer this in a very high level in that AER paper a few years ago on brands and brand preferences. But I don't think there's a really definitive paper out there yet that really talks about what happens to people when they're young. What do you drink as a young person will determine what you'll drink for the rest of your life. I'm not sure I entirely agree with that. After all, in our paper, while we say consumption capital is persistent, it's not like the depreciation rate is zero, right? So all this says is that people are going to form behaviors, and we should expect to see a lot of inertia in those behaviors, but that doesn't mean we don't see any deviations from these behaviors. And as I mentioned a moment ago, even amongst the baby boomers, it's not that they're drinking 0% craft. They are buying some craft beer. It's just they're not switching as fast as the millennial generation, and that they're not, even though it's a bigger group, they don't seem to be driving the growth in craft beers. And that's what I think is the interesting thing. But I think the second bullet point, I think this is a much stronger statement than what is actually implied by the model. And then, of course, the service to the readers, Ella suggests some discussion about state dependence in learning. Absolutely. I think this is more of an acknowledgement than anything else, because, well, I'm using the structure. We are using the structure of this consumption capital formation. It's true that we're not really digging deeply into why this is consumption capital, and is this a learned behavior? I'll making a reference back to the Stigler-Becker paper, where they describe consumption capital as the analogy of music, and their argument is everybody has a preference for music. It's not that some people like it more than others, but over your lifetime, as you start listening to more music, you start figuring out a listening habit, right? And it's not that some people are music people and other people are not music people. It's really about forming that music habit. And I guess that sounds a lot like a learning type argument. But again, this is yet another bullet point that I say, although I'm going to acknowledge this in the paper, absolutely, but it seems like this is a really neat opportunity for any PhD students looking for a research topic, which is trying to understand what is this consumption capital and what drives it. There's some other sort of more technical suggestions and comments that Ella raises in her deck. She asks about modeling implications. She seemed okay with our time invariant preferences, but was worried about the youngest people in the category. I think the comment here was that we kind of had this either-or structure to the model. It's either a totally unmalleable and totally unmovable preference, that's the intrinsic part, or it's consumption capital. Well, why couldn't there be like some blurring of those two? The answer is, for this research, we literally just wanted to isolate the effect of experience. And to that end, we are also the alternative explanation is that millennials are somehow generationally different. But she's absolutely right. If we were trying to build a model of demand and trying to forecast demand in a serious way, or do marketing, do it something normative, there's no reason to think that the other part of the equation has to be absolutely time invariant. There could be multiple mechanisms acting simultaneously. And then I agree with her comment on the managerial implication. And this is something that Ram and I chatted about in the first 5 minutes, about marketing to the young. And then after that, Ella sort of ended off with some editorial comments. I don't know if she'd planned to mention these. Clearly, she didn't run these slides by Peter Rossi before doing them, because she would have probably been told by Peter that significance levels in tables are like the bane of science. As you all know, Peter is not a big fan of significance tests. We do disclose all the standard errors, so you can certainly manually calculate all the significance levels you want, but I'm going to defer to the Rossi critique here, and I probably won't put significance levels in the tables. Peter, if he's listening, will probably deny and dispute this. Well, it's always fun to show that I'm wrong. Adding units, no problem here. There seems to be some editorial things, but I think largely here, the main comment here is that Ella got fed up reading our section 5, which was too long. So with that, thank you very much, Ella. Totally agree on these implications, and totally agree that there's a lot of work yet to be done understanding how people initialize their preferences. So even then, when I become an adult, do I inherit some preferences from my parents or my peers? And then more importantly, digging more deeply into the mechanisms that we're calling consumptional capital and seeing if they're the same or distinct from other structural models like loyalty and state dependence, or learning and other kinds of things like that. All right, so I think we're at 12:03. I'll finish with that, and I guess we adjourn for lunch now. Thank you all very much, and thank you, Ella.
Actually, I think I'm presenting now over here. So let me get my...
Even better. So let me unshare here.
Yeah, that would be great. And let me share